To power or test your electronics, having a bench power supply is a must. In this video, I will build a basic power supply with which we can control the voltage as well as the current. Let's get started. I will use this NewStar adapter, which can provide an output voltage of 12 volts, 13.8 volts, 18 volts and 24 volts respectively, with a maximum current output of 6 amps. Before getting started, I measured all the output voltages which were not satisfactory. All the output voltages are higher than the rated voltage. So I opened it to have a better look at its circuitry. This is the circuit after tracing. It uses a transformer to step down the voltage to provide 12 volts, 13.8 volts, 18 volts and 24 volts respectively, which were connected to a switch. It has a bridge rectifier circuit using 1N5401 diodes, which will basically convert the negative half cycle of the AC signal into positive, which is fed to a capacitor filter having 3300 microfarad 35 volts capacitor and a 2200 microfarad 35 volts capacitor connected in parallel, whose total capacitance will be 5500 microfarad to get a constant DC output. I will operate the adapter in 24 volts, connecting the positive to the positive rail and negative to the negative rail of the breadboard, and connect a 0.1 microfarad capacitor between the positive and negative of the power supply, adding a current limiting resistor of 1 kilo ohms in series with an indication LED. I will use LM317 voltage regulator. According to its datasheet, it can support an input voltage range of about 4.25 to 40 volts. Connect its input to the VCC and connect a 220 ohm resistor between its output pin and the middle terminal of the potentiometer. Connect the first terminal of the potentiometer to the adjust pin of the voltage regulator and the last pin to ground. When I rotate the potentiometer knob, the output voltage also varies, but the temperature of the current limiting resistor was increasing a lot. So I added a potentiometer in series to increase the resistance, which I will remove it later. I connected an ammeter and a voltmeter at the output and set the output voltage to approximately 12 volts and connected a 12 volt DC motor as a test load, which consumed nearly about 0.5 amps of current while running and about 1 amps during initial start. According to the datasheet of LM317 voltage regulator, it can support output current of about 1.5 amps, which should just work fine. But I also wanted to control the current supplied to the load, for which I used BD139 transistor, connected the motor to emitter, which consumes 12 volts and 0.5 amps. Therefore, the collector current required will be 0.5 amps. According to the datasheet of BD139, it can support a collector current of 1.5 amps and collector emitter voltage of 80 volts, and also provided DC current gain from 40 to 160, which is perfect. Assuming DC current gain as 100 and calculated the base current, which came to be 0.005 amps. Considering the base resistor as a potentiometer of 10 kilo ohms, which when varied will vary the collector current. Connect the output of the voltage regulator to the collector pin of the transistor. Connect the middle terminal of the potentiometer to the base, first terminal of the potentiometer to the collector and the last terminal to the emitter. Connected an ammeter and a voltmeter to the emitter, which is output. I was able to control the current flow. But what if the load is like this motor? It is a 24 volts DC 100 watt motor. After the calculation, it consumes 4.16 amps of current at full load. As we know that our transistor and the voltage regulator can provide maximum output current of 1.5 amps. Therefore, I will use TIP3055 power transistor. According to its datasheet, it can support the collector current of 15 amps, collector emitter voltage of 60 volts and base current of 7 amps. which is perfect. Connect the base of TIP3055 to the emitter of BD139, collector of TIP3055 to VCC and an ammeter and voltmeter at its emitter and tested it. I added another TIP3055 power transistor in parallel and tested it out again with some load. Motor consumed nearly about 2 amps and also had a voltage drop. Well, with all this being said, the circuit was working fine. If there is any way that this circuit can be modified, then comment down below. A like will be appreciated and do subscribe.